For this part of the review, I want to just address the misconception I saw in the in the cool down for last week. A lot of you got confused. I think the only period that got almost 70% like of the class correct was my honors. But I want to make sure that everybody understands how to do this. So first thing that you need to know is the following. Small standard deviations mean skinny, okay? Just in plain simple English. And then fat standard deviation means large. Fat graph means large standard deviation. Skinny graph means small standard deviation. That's it, okay? Now we can read the problem. So it says, draw a second normal curve on the same axis as the first with the new properties. So what we're going to do here is that we're going to draw, okay, on top of this curve right here, what they give you for you to do, okay? So if they tell you, by the way, I wanted to show you something before I move on. So I'm not really sure if you're aware, but you can draw in these slides, okay? You just open a new Google Slides here, and I send you the PDF file so you can access it as well. If you don't have a printer, you can simply go here, you open the PDF file, and then this PDF file have something that's called take a snapshot. So you just click on it, and then you take the snapshot of whatever you want in the document. You go to your slide here, you cut and paste, and then here you go in this feature here, and then you put scribble. So if I say that I want to shade one standard deviation within the mean, you just shade that region, okay? That's one way that you can practice this without having to print this out if you don't have any paper, or if you don't have, wait, what happened? Where did it go? Well, anyways, that's the idea. I don't know what happened here. It stayed. Maybe I did something wrong. But anyways, if that's all you want to do, oh, there it is. It will stay like that, and then you can just go and check if you did it correctly. I will provide as well. I provided you as well with the answer sheet, so you can just check. But you don't have to print this out if you don't have a printer. All right, so let's go back here. So it says here the mean is the same as the standard deviation. The mean is the same and the standard deviation is smaller. The mean is the same. Where is the mean? That's the first question you need to ask yourself. Well, the mean is in the middle. So they're telling me here that the new curve I need to draw needs to be the same mean. So that means that I'm not going to switch this to the right or to the left. It's going to stay where it is because the mean is the same. What is different is the standard deviation. The standard deviation is smaller. So if my standard deviation is smaller, automatically you should be thinking that your curve will be very thin. So that's it. Create one that looks thinner than this one, but without changing the position of the mean. So it will look something like that. And hopefully for those of you who, this is a little clear, you probably did in your head. And yeah, it will look like that, okay? It will look thinner than the regular, bell shape as it is. Okay, let's do the next one. The mean is smaller. The mean is smaller. And the standard deviation is the same. So, is it going to be fatter? No. Is it going to be thinner? No. Will it change positions? Yes, it will. If this is your number line, okay, remember a 0 will be here, right? 0. And then the farther you go from 0, the larger the numbers. So they're telling you here that the mean is smaller. So that means that this is tailing to the left of the number line, right? So if the mean is smaller, that means that it has to be, in this case, to the left, if I'm seeing it this way, right? To the left of the normal curve. Okay, that's really it. And that's what I was asking you in the cool down. Like, if you have, what's the difference if the mean is smaller or if it's bigger or larger? And some of your answers were like, it's gonna be distributed evenly, and some of your answers were like, what are you talking about, right? But it was probably because you didn't understand. But that's all it means, okay? It's not extremely complicated. It's just looking at the number line and then understanding that if the mean is the same, you're not moving anywhere, but the standard deviation is what dictates if it's skinnier or fatter than the normal bell shape. Okay, next one. The mean is larger and the standard deviation is the same. Okay, again, is it going to be small? No. Is it going to be skinny? No. Is it going to be fat? No. Is it going to change positions, the curve? Yes, because the mean is larger. So that means it's going to be switched to the right of the normal curve because the mean has a larger number. So the mean here, for example, might be, I don't know, 10, and then here it might be 20. Okay. Just to give you an example. All right, go ahead and do the next ones. Go ahead and do these ones, and then we check our answers. So the mean is smaller. The mean is smaller, and the standard deviation is larger. The standard deviation is larger. So is it going to be fat or is it going to be skinny? And it's going to be switched around. So let's check. Yes to some of those, right? Is fatter, okay? It's like more spread because the standard deviation is larger, but it's also shifted to the smaller mean, to the smaller numbers, okay? And then the next one says the mean is larger. The mean is larger. So my center of the data will be a larger number. So that automatically should tell you what to do. And then the standard deviation is smaller. Smaller. What does that mean? Is it going to be fat or is it going to be skinny? So hopefully you said it's going to be skinny and it's going to be shifted to the right. And that's exactly how it looks. Okay, so we're going to stop here. And then I'm gonna show you the last part of the review session I wanted to do.